Assalamualaikum everyone. Today I'm going to be showing you the project that I've been working on, which was for credit card fraud detection. As you can see over here, that this was taken off of Kaggle. First, as you can see, is that these are all the modules that I used. I then used pandas to load the CSV file into a data frame, and its shape was 31 columns by 284.8 rows. As you can see, that the columns were time, V1 all the way through V28, amount, and class. V1 through V28 were all masked variables. Class told us whether the transaction was fraudulent or not. As you can see, there were a total of 492 fraudulent transactions and 284.3 thousand were non-fraudulent. I then went on to create different x-axes for my dataset. The initial one was just taking out the class as a y-axis and taking the rest of the variables as my x-axis. Then I made another dataset which removed time from the entire DFX, and then another one which was like the original x-axis but without the time variable, and amount was unscaled. And then I made df2x which scaled all of the masked variables, df3x which added time back into df2x, df4x in which everything was scaled including time, df5x which was like df4x, everything scaled except that the time variable was removed. I then went on to define this function which would score all of our models. It would take in the model, fit it according to the train test split that we are going to conduct over here, apply these different data frames from dfx all the way to df5x as I showed you earlier, and it's also going to pickle each model into a different file, and that file would be stored onto our Explorer. Pickled files are basically used to store objects which can be recalled later in order to save us time of the fitting process. Another thing this function would do is basically append all of these data into a table called model scores. This would be appending the model name that we use, the data frame that we use, the ROC AUC score, the F1 score, and the duration it took for that to be completed, as well as displaying the confusion matrix below. The models we chose to use were logistic regression, random forest, decision tree, gradient boosting, and k-neighbors classifier. As we can see, once the model was run, all of these started to show up. These are different confusion matrices. It's telling us which model was used with which data set, what was the ROC AUC score, and what was the F1 score against each, and the time taken. Initially, my gradient boosting was giving me a very low score, so I ran this grid search cross-validation in order to get the best parameters that I could use for gradient boosting. As a result, I was told that the Friedman MSE with 0.05 learning rate, nice step 3, sample leaves 0.1, and n estimators of 10 were to be used to obtain the best possible result for gradient boosting. After running the scoring models function again, I got this data frame of model scores, which is telling me how each model did with each data frame. And it gives me a summary of all the ROC AUC scores with the F1 scores and the duration. Grouping the table up by data frames used, you can see that df1x, df4x, and df5x performed the best in terms of AUC and F1 scores. And then grouping them according to the model used, you can see that random forest, gradient boosting, and decision tree was quite effective as well in terms of both AUC and F1 score. I chose to go with the random forest classifier using the df1x data frame, as the df1x was very close to the original, only excluding the time variable. It gave me a very high ROC AUC score as well as a very high F1 score. In order to test our model, I had to export the test X like this. I made the front end so that any user could upload any file and it would just make that uniform according to the training of the model, and then use that data frame in order to predict by using the random forest classifier model, and the prediction will be given out as an output. Okay guys, let's test out our model over here. This is the Streamlit application I made using the Python file I showed you earlier. Let's upload the test text file that I had exported using the Python notebook. As you can see, it just takes a little bit to upload all of this. It's a 9.6 MB file, and this is the dataset that we had inputted, and this is the output that we received. Considering it's such a highly imbalanced class set, I would just sort this according to descending order. You can see what index has what outcome and which ones are considered as fraudulent transactions over here. And that's it guys. I just wanted to say that this would be a very useful model for banks and other lending agencies which would give out credit cards or other such instruments against which people may file claims of fraudulent transactions. This can help save such institutes the cost of actually researching and investigating all of these cases by using this model. Also, a few of the issues that I had faced during this entire project was one of the gradient boosting low score, which I fixed using grid search validation, and also the setting up the front end on Streamlit took a lot of effort and used a lot of different debugging methods as well. And that's about it. If you have any further questions, please ask me. Thank you.